Video is about an example of Leontief's analysis. It's common problem C7. So you have to go to the common problems. Topic 1, linear algebra. Linear algebra is in the content section of your campus virtual, and there you look for C7. At this moment, you should pause this video, stop it, put the problem in display, print it, read it, because I'm not going to write the statement here. Pause the video and read the problem. It talks about an economy with two industries. One is oil and the other one is cars. So the oil industry, to produce €1 needs 70 cents of oil, 0.7 euros of oil itself, and 0.3 of the cars. While the cars, to produce €1, they need 0.2 from oil and 0.7 from cars. So if we call the production of oil, we denote it by X, and the production of cars is denoted by Y. We have for X euros, we require 0.7X and 0.3X. So here is the production of both sectors. Here, this is oil, and so is this one here. So this is the requirement of oil by the oil industry, should be produced by the oil industry. So here it goes, 0.7. And this depends on how much oil we produce. So that's the X there. But this is a requirement for cars. So it should be made by the car industry. So it goes down here. When you have that clear, the rest is easy, because this is the cars, 0.2Y and 0.7Y, oil and cars. Then it's easy. This is oil, again goes into the oil, so plus 0.2Y. And here will come this thing, 0.7Y, plus the external demand, which is 9800 and 6900 respectively. Set the system, we write it as a matrix, so xy equals to 0.7, 0.3, 0.2, 0.7 xy. These here are the coefficients of this part. So similarly, the coefficients are 1x, no y here on the first equation, and no x, 1y on the second equation. We're missing the external demand, so we add it as a different matrix here. And we move this to the other side, and we have 1001 minus 0.7, 0.3, 0.2, 0.7. This equals to 0.3 minus 0.2 minus 0.3, 0.3, and we call this matrix B. So our system right now is B times XY equals to the demand, which I'm going to call D. This matrix of demand, which is 9800, 6900. So BXY equals to D gives us, moving the B here, XY equals to the inverse of B times D. 1 second, let's put just simply D. So this is what we have to, for which we need to compute the inverse of B. How do we do it? So B is equal to 0.3 minus 0.3 minus 0.2, 0.3. The determinant of B is equal to 0.3 times 0.3 minus 0.2 times minus 0.3. That's equals to 0.09 minus 0.06, 0.03. So the inverse is equals to 1 divided by the value of the determinant, and not these two here, this and this have to be exchanged in position, but as they are equal, you don't see anything. And this one here, along with this one, change the sign. Now I'm going to try to avoid to use decimals so my computations can better. 0.3 divided by 0.03, this is 10 times this. So this is 10, 10, and 10. And this will equal 20 thirds. So our solution, xy, is equals to this matrix, 10, 10, 20 thirds, 10, times 9800, 6900. Now that's equals to 9, 8, and 3 zeros plus 20 over 3 times 6900. See, I have not used decimals because this number is divisible by 3, so computations are going to come quite okay. 0, 0, 0 plus 69000 becomes equals to 144,000 and 167,000. So the answer is the production of oil is equal to 144,000 euros, and the production of cars will be 167 euros. The problem is also asking what happens if the external demand increases by 2%. That's per se. What if demand increases by 2%? In that case, well, think about it. You produced, for a demand of 98 and 69, you require, this is the demand, you require a production of 144 and 167 as production. Think about it. If you have 2 times the demand, you would require 2 times the production, right? And if you have 10 times the demand, then you would have 10 times the production. So if the demand increases by 2%, increase of 2% is 1.02 times the demand, will require you 1.02 times the production. So your answer, the new production, will be equals to 1.02 times 144 and 1.02 times 167. And that's equal to, the new production is 146,880, and for cars is 170,340, and that's your new production.